target lesson for the day. You're going to leave here saying, I can simplify square roots. And let's start off with getting a little foundation, because this is where a lot of students start getting confused on what the problem is asking you to find. A lot of students want to give me the approximation of a square root, which is a decimal representation that usually involves rounding. And we use our TI-84 calculators, which you should have handy. And we're going to go through these 3 steps here as we try example 1 that says approximate, meaning that your answer will have these little squigglies instead of an equal sign. It means that it's about. The approximation is about. It's not exact. That's what we're going to be finding next in the next part of the lesson. So as we go here, turn on your calculator. I'm going to clear out whatever's on there. I'm going to hit the second, which is blue. The X squared is on the left side of the screen. We've used that button before. And then I'm going to type 10 and hit enter. And when I do that, I get 3.16 and some other change. Now it says round this to the hundredths place. So after the 6, I look, it's less than 5. So I keep 6 where it is. So this is approximately 3.16. So when you see the words approximate, that means give me a decimal, and your answer should involve this symbol. All right, next, square root of 45. We'll type it in, just the procedure we've been doing. 6.708. The 8 tells me to round the hundredth on up to a 1. All right, and finally, square root of 17. 4.123. The 3 tells me to keep the 2 where it's at. Approximation symbol 4.12. So you'll be doing some of this on the homework today, but you're only looking for decimals when it says the word approximate. Now for the actual part of today's lesson, where we start looking at simplifying. We have these 5 steps that we'll read through as we go through our first example, which is number 4 down here. Let me just get everything back on the screen as it should be. All right. So we're simplifying, meaning we still want a radical in the answer. We do not want any decimal. We want an exact answer, so we should have the equal sign. So I'm going to go ahead and do the equals to set us off. It says, find the perfect square that divides evenly into the content of the radical. Now, 8, I'm going to go ahead and write out its factors like we did before. 1 times 8, 2 times 4. That's the sets that will multiply to get you 8. I don't repeat them. The biggest perfect square I see would be 4. I'm going to circle it. So I'm going to go ahead and write that as the perfect square first. 4 times 2. That's going to be our step 2, where we write the product. Step 3 is where we actually break the product apart, just like this. And now we take the radical of the square root. Square root of 4 is 2. Radical 2 stays behind. And this is our answer. Now, if we move on to the next one, we've got 12 under the radical. Now, 12 would look at its factors of being 1 and 12, 2 and 6, 3 and 4. So we have more options now. And I see a lot of students saying, I'm just going to go ahead and use this last option no matter what it is. We can't do that. We have to look for the biggest perfect square. The one that we always have here doesn't change anything. It's not all that interesting. So I usually cross it out or just ignore it. I cannot use the 3 because it's not a perfect square, but I could use the 4 because it is a perfect square. I couldn't use the 2 and the 6 because neither of those are perfect squares. All right, so this is going to be the radical, 4 times 3. I break the radicals apart. Square root of 4 is 2. Radical 3 stays behind. All right, next we've got radical 50. 50 would be 1 times 50, 2 times 25, and 5 times 10. For this problem, I see a lot of students try to use the 5 and the 10, but notice neither 5 nor 10 are in the perfect square list, so I cannot use them. The 1 and the 50 doesn't change anything, but the 2 times 25 contains a perfect square, which is the 25. So I'm going to put the 25 first under the radical symbol. I'm going to break the 25 apart and the 2 apart underneath the radicals. Square root of 25 is 5. Radical 2 is there for the ride. Our last example on this row would be 10 under the radical, which would be 1 and 10, 2 and 5. Now, 2 and 5 contains no perfect squares, and 1 is a perfect square, but it wouldn't actually change anything here. So this one will not simplify any further for simplification. As for your guided practice, I encourage you to go ahead and pause the screen. I'm going to go ahead and put the answers up here. And if you have questions, you can send me an email. I'll be happy to address those. Square root of 18 is number 4. Square root of 27, number 5. Number 6 is square root of 75. And 7 is square root of 15. So pause the video now if you'd like to attempt those and come back when you're ready for the answers. Number 4 is going to be 3 root 2. Number 5 will be 3 radical 3. Number 6 will be 5 radical 3. And 7 is just itself again because 15 doesn't contain any factors of perfect squares besides 1. All right, moving on along. If there are no questions, we'll move on to the next set of examples. And these are different from the first set in that there's something in front of it, whether it be a fraction, an integer, or anything. We'll talk about how to address that. Number 8 says 6 square root 24. Now this time I'm not going to write out the perfect squares. We'll just discuss them as we're solving. So the 6 is going to stay where it is. And I'm going to put the radical symbol right there for the 24. Now, the biggest perfect square that goes into 24 is 4. And the other number that you use would be 6. I'm going to break these apart. 6 times radical 4 times radical 6. Now I have the 6, square root 4 is 2, and then radical 6 just is there for the ride. Now 6 times 2 is 12. Radical 6 is there. So 12 radical 6 is our solution. Now number 9, we have negative 2 radical 40. So again, without writing out the factors, I think about 40 being the product of 4 and 10. Again, I cannot use any other sets because they don't contain the largest perfect square. So I'm going to break this down. We got negative 2. We've got a radical 4, and it's multiplying with a radical 10. Radical 4 becomes 2 outside the radical. Radical 10 just stays there. We have a negative 4, radical 10 as our solution. Finally, with number 10, we have a fraction. It is 1/2 radical 28. What we want to do is to find the biggest perfect square that goes into 28. And I believe that is going to be a 4, and it multiplies with a 7. The 1/2 multiplies by radical 4, and that multiplies with radical 7. 1/2 times radical 4 is going to become a 2, and then radical 7. We have 1/2 times 2 is 1. Radical 7, or just radical 7 as our solution. All right, if you'd like to pause the video now and try the next row of guided practice answers, I'll supply the answers whenever you're ready to hit play again. Number 8 for us will be And I'll place up the work here as well. 3 radical 18 becomes 9 radical 2. Negative 5 radical 50 becomes negative 25 radical 2. And finally, 1/4 radical 12 will become 1/2 radical 3. All right, guys. If you will check the stream of Google Classroom, you will find the latest homework set under the chapter we're studying on there. It is this sort of thing that asks you to approximate and simplify. Make sure you're doing the right thing based on what the problem asks of you. Email me with questions, and don't forget there will be an exit slip to follow after the homework. All right, have a great day, everybody.